Hi guys, so this is question 7 from the partial fractions section of the homework. The question gave us a function in terms of x, and we were asked to do loads of different things with it depending on the different part of the question. The first part asked us to write it as partial fractions. This one is a nice straightforward. We've just got two linear factors here, so all we need to do is say that it was going to be something over one of the factors and something else over the other one of the factors. Okay? We know from our use of partial fractions that we can therefore make this a common denominator. So the top must be a multiplied by x plus 3 in order to keep this equivalent. Now that I've got something extra on the denominator, the top does 2, and the same over here. Okay? This is equivalent to this, and the bottoms are the same, so we can just multiply those out, and we get 4 is equal to a, lots of x plus 3, and b, lots of x minus 1. We can use the comparing coefficients method here, or if we want to, we can also use the cover-up method, which is what I'm going to do now. So I'm going to let x equals minus 3 in order to cancel out this bracket and just leave me as an equation in terms of b. So what I've got here is I've got 4 is equal to nothing, add minus 4b. So therefore b is minus 1. I'm going to do the same now and remove this one by letting x equal 1. So what I've got is 4 is equal to 4a, now that x is 1. So a is 1. So I know that it is 1 over x minus 1 minus 1 over x plus 3. The next part of the question asked me to differentiate it and show that it equaled this. So what I'm going to do is take my partial fractions from the previous question and just write them in a little bit of a better differentiable form. Okay? So what I've got is x minus 1 to the minus 1, take away x plus 3 also to the power of minus 1 as it's in the fraction. Okay. Now I'm going to differentiate this. I'm going to use a chain rule to do so. So I'm going to bring down the power of the bracket and reduce the power by 1. I'm now going to multiply by what is inside that bracket differentiated, which is actually just 1, so we don't have to worry about it too much. Same here, I'm going to take away this, bring down the power, reduce by 1. Again, multiplying by whatever is inside the bracket is differentiated using the chain rule, but it's just 1, so we don't need to worry too much. And what I've got here is minus 1 over x minus 1 squared. This now becomes a positive 1 over x plus 3 squared, which is what I was asked to do. Okay. Part 3 of the question asked me to work out the turning points of this. So what I needed to do is find out where this equaled 0. So what I did is started by writing in the equation, this equals 0, taking this over here. I've got 1 over x minus 1 squared is equal to 1 over x plus 3 squared. Now I just need to solve this for x. So what I notice is because these are both 1 over something, these must equal each other, or you could think about it that I've multiplied like that. So what I've got is x minus 1 squared is equal to x plus 3 squared. All I need to do now is expand those out, make them equal to 0 and solve it. Making it equal to 0, these cancel out, this can become an 8x, and the minus 9 can be brought over to become minus 8, so x is equal to minus 1. So that means we've only got one turning point. The question only asked us to find the x coordinate, so we didn't need to substitute it in to the original, we could have left it at that point. Last part of the question asked us to determine the nature, so we know we need to find f double dash x in order to determine the nature of a turning point. So I'm going to take what I had here, I'm going to write out what the first differential was, but in a nice easy format. So I'm going to call that minus 1 over x minus 1 to the minus 2, plus 1 lot of x plus 3 to the minus 2. Now that makes life easier. Apply exactly the same method as here. The second derivative, bringing the power down, and reducing by 1. Again, multiplying by what's inside the bracket differentiated, which is just 1, so that's fine. And the same over here, bringing down the power and reducing by 1. Now I just want to simplify, so I've got 2 over x minus 1 cubed, take away 2 over x plus 3 cubed. I now need to work out what the second derivative of my turning point is going to work out to be. So I'm doing 2 over here, minus 1 minus 2 cubed, take away 2 over minus 1 plus 2 cubed. So what I've got here is minus 2 eighths minus another 2 eighths, which is minus a half. That is less than 0, so my turning point is a maximum. Okay, thanks.